Great. So very briefly, I will just talk a little bit about who am I, what is Engagor, what is Engagor's product, what is the context, so social CRM. I will show you a little bit of the Engagor platform, so what it does, the analytics and so on. And then I had prepared 2 case studies. Anyway, we'll see how far we get. Just last week I saw this this picture on KD Nuggets about what it means to be a data scientist, and at the bottom there is a specialization is for engineers, so as I said, I'm an engineer. But actually I'm not really a typical engineer, because I graduated here, then I went to Brussels to do a PhD in artificial intelligence. Actually before that, tried to do a PhD in nuclear physics. I also did some biology. The bottom line is just, I think I agree with most of what is said here. To be a data scientist, I think you don't have to be a specialist in anything. You have to be you have to have a broad set of skills. Someone said you have to be better at statistics than a coder and better at coding than a statistician or something. I don't know. So I agree with most of these things, except maybe the arguing R versus Python. I don't like either of them. And I do pretend to know a little bit of deep learning, but that's just pretending. Anyway, so this is a picture of the Engagor team quite some time ago. In the middle you see Volker de Metre, who was the founder. So what is Engagor? It is an all-in-one social customer relation management platform. It's a software as a service platform. So it allows you to monitor whatever you want to monitor on many channels, but specifically social media. It was founded in 2011 by Volker, and it was acquired, as you may know, in last year by Clarabridge, an American company. So in between there was quite a steep growth and so on. So by now we have over 400 customers. This is only Engagor, it's not Clarabridge. And we handle about 300,000 cases per day. So what do I mean by a case? It is like the people who use our platform, they are sitting behind the computer using the platform all day to see whether people have questions on social media and so on. They have to handle these cases. So there are about 300,000 cases like that are handled through Engagor per day, which you can see here, the number of cases over time last month. So mostly all the most cases are in English, as you can see here, or maybe not. So this is English. We also have quite a few cases in Arabic, which is the second most used language in Engagor. Dutch, Turkish, French, and so on. We support over, well, I don't know, maybe 168 languages, which means that we can detect these languages and several other stuff. We don't support them in the sense that we have sentiment analysis for that, for all those languages, for example. But just to give you a bit of an idea, what is social CRM? So as you probably know, consumers are becoming increasingly social, vocal, mobile, and brand engaged. And they're spending a huge amount of time on social media. I know because I have some daughters. I can't even talk to them anymore because they're always looking at their phone and so on. And they prefer, they also have high expectations about how brands and organizations and companies, how they can interact with them. So, for example, 72% of people expect a response for complaints within the hour. And if they don't get that, they tend to prefer another brand or switch to another brand and all these things. So just to illustrate you that monitoring social media and being able to rapidly interact with people and with what people say on social media has become very, very important. over the years. And so that's where Engagor comes in. It enables brands to have personal conversations with customers on a global scale. Right? So you can track all the conversations that are of interest to you. You can use the analytics, and you can do a lot of automation and so on to filter the noise and keep the signal, and then respond appropriately to whatever you need to respond to. So this was going to be a demo, but as there's no internet, I already took some screenshots of the Engagor platform. So here you can see just, these are just some illustrations of the kind of analytics that we provide. So on top, the number of mentions you have tracked or replied to and so on. Per region, you can compare not only per region, but by many other things as well. You can see what kind of sources your data came from, the sentiment, and so on, also per region. We also offer certain solutions to get more insight into the data that you have, like these kind of trending topics, and so on. And all these things are, well, we also have demographics. Most of these things, by the way, are powered by Elasticsearch, if you were wondering. So Elasticsearch allows you to do very, well, sophisticated analytics already with aggregation and so on. Right, so that's one part of Engagor, the analytics part. And another important part, of course, is the inbox. So you can think of it as kind of a mailbox, like Inbox by Google, which is the place where the people using Engagor are working in every day, right? So on the left you can see a number of mentions, so things that have been tracked, and then the main view shows you the mention that you're currently working on. And then what is important here for me now is that you can do a number of things on such mentions. For example, you can change the sentiment, so we automatically detect the sentiment, but it's not always correct. Or you can attach tags to mentions and so on. So for example, these three things colored here, these are already tags that were already added, but you can add more tags and so on. So the main point here is that Engagor offers a rich and challenging environment for doing data science, requiring a broad range of skills. So there's large amounts of data that have to be processed in real time in a robust way. So all the analytics have to be real time, and it also offers a unique perspective because what the kind of data that I'm working with is data produced by people using our platform. So it's not really the data that is generated by the people on social media, but how that data is being processed, right? So this offers the opportunity to learn from that, from the process of processing itself. So, which allows, for example, for personalization and online learning. So, what do I mean? So here, the firehose is the source of all the mentions that are coming into Engagor. And so the first thing that happens is they go through this AIS. So this is the Engagor AI service, right? Which determines things like sentiment. Then they are indexed, Elasticsearch and so on. Then they're handled by the people using Engagor, right? So here you already have a number of predictions. These predictions might be changed, like for example, sentiment was not correctly predicted, so it's changed here. And then users resolve the case, so the mention is handled, and then it goes back to the AI service, which means that we have a continuous predict-learn loop, which we can use to streamline this entire process so that this is made more easy and can be done more efficiently. So, what does the AI service do? It calculates the trending topics. I'm not going to talk about that. The two things that I want to focus on now are the tag suggestions. So I showed you that you can attach tags to mentions. So what we do is we try to predict the tags that are going to be attached to the mention. So at this point we have quite a large number of online machine learning models for that. And so the learning is really, and prediction is really being done in a real-time, continuous way. Another thing that the AI service does, as I said already, is the automatic sentiment detection. So, so far we mainly use offline learned maximum entropy models for that, based on OpenNLP, but that doesn't really matter. In 8 languages, but we're really experimenting as well with trying to use that prediction learn loop to have online learning sentiment analysis. It also calculates a number of metrics, like so, for example, the graphs I showed before are calculated by the AI service. It's written in Clojure, and we also C++ in the sense that we use Focal Webbit, which is by Microsoft, by the way, for the machine learning. Right, so let me get to the case studies. First case study, tag suggestions. Just to give you an example, what kind of tags, so these are examples of tags that are used by one of our clients. It's a telecom operator. So they have, so what this graph shows you is that most of the mentions have 0, 1, or 2 tags. Like about 1/3 of the mentions don't have any tags at all, and so on. And here, what this shows you is the percentage of mentions that have a particular tag, right? So it's just to give you an idea of what kind of data we're dealing with. These are graphs of the frequency with which some of these tags occur, right? So important to notice here is that some tags only occur in bursts, like typical for technical trouble. Some tags didn't exist before and are started to be used only at a certain point. Others can disappear and so on. So we wanted to build a system that is able to cope with all these things and learn all these things, right? So there are some challenges to building that system. So there's no easy way to know the set of active tags, because that can change all the time. So we have to measure that some way. We also, of course, because there can be thousands and thousands of tags, we have to manage thousands and thousands of models, each with possibly different feature sets and learning parameters. For example, if you want to do something like simulated annealing or so. Has to be high throughput, and we have to be able to monitor performance. So this is something that we actually did. We asked for subsidies by the IWT for this, and then we, I think it was last year and a half ago, that we started building this system. So what kind of solutions did we apply here? We monitor all the frequency with which tags are used, so how many mentions do have a certain tag and so on. And then we decided just to learn and predict only those tags that occur often enough. That's some kind of threshold. We use the hashing trick, meaning that we don't have to decide beforehand on a specific set of features. You just map each feature to a unique hash. Well, not unique, that's something else, but anyway. And then another thing that was highly, that was very interesting for us by using Vocal Webbit, I don't know if you know, but it supports the idea of namespaces, so you can put different features in different namespaces. So you can actually have one running instance of Vocal Webbit that corresponds to as many machine learning models as you have namespaces. Right? So you can also easily add a new model, so to say, by just defining a new namespace. That was also interesting. Okay, so let me continue with showing you a bit of the performance of this system. So above you can see the precision and recall. So this is a macro view in the sense that it's over all the tags that are being predicted. So we have a bit of a higher precision than we have a recall because, well, that's a choice in a sense, but you can see it's okay for having a general set of features. So it's about 80% of the time it's correct, and about 70% of all the tags are being predicted when needed. A more micro view here you can see in blue the number, well, in total the number of times a certain tag occurs, and then in blue the number of times that it was actually predicted or per account. So this is an aggregation over a number of tags per account and so on. So I think, well, I mean, this shows that we have a working system. And here I already showed you the kind of top graphs. So this was the frequency of occurrence of a certain tag. Actually in red you can see the frequency with which the tag actually occurs, and in blue it is the frequency with which the tag is predicted. So that's already looks quite good. Yes? Yeah. Now anyway, this doesn't really say anything on itself. You also have to look at recall and precision values. So here you can see how these evolve over time. So typically what we see is that here, well, that for example, precision and recall goes up when the tag actually occurs. So because then there's also more training examples. Yes?
So are you using hashtags or you're tagging via semantics?
No, these are just user tags. So
these are user tags like hashtag, like.
No, it's not tags that occur on social media. It's not like a tag on Twitter. It's a tag that is added by a user of Engagor. For example, a tag that says, this is a tweet about a complaint about technical trouble, right? That's what I meant with the unique perspective and unique kind of data that we can work with, right? Also important to show here is, well, that indeed the system is able to pick up new tags and so on. Good, that completes the first case study. The second one will be even shorter. The challenge with the sentiment, so sentiment analysis is quite hard. There are many reasons for that. One, of course, is because you need to have a knowledge of grammar and all these things, which we don't. I mean, our models don't. But there's also some other challenges in the sense that what is positive for one user could be negative for another user. Say something like, I hate Telenet, but I love Mobistar, will be, and so on, right? So another challenge is that what we noticed, our users, so the users of Engagor, tend to be overly positive. I don't know why, there are many possible explanations for that. So, but the challenge here is, so what do we want to do? We have all these mentions that are being processed by the users of Engagor. They are changing the sentiment, they are correcting the sentiment, and we want to use that data to train a sentiment model. But we have to deal, for example, with the bias that is present in that labeling by our users as well. So to illustrate that problem, this is something that happened and which was not very good. This is the fraction for each sentiment class, so we have positive, neutral, and negative, of predicted sentiments and actual sentiments. Don't mind the bottom graph. So normally this is a typical distribution over the classes. And then at a certain point it started increasing, and then actually at this point here, some of our clients started complaining and say, sentiment is way off, what happened? And so what did happen is that the online learning sentiment classifier was learning to be overly positive, and then so there was a positive feedback loop, right? So then I thought, how are we going to solve this problem? And so the solution, I think, is online calibration. Meaning, what we did is we just defined an external independent test set. So then we can use the online learning classifier to predict the sentiment for each mention in the test set and see the fractions of sentiments predicted by that classifier. And then we can compare that with the target fractions, and then we can introduce a bias to the classifier to compensate or counter the user bias. Right? So these are some of the things we do data science related at Engagor. Thanks. Any questions?
What is your revenue model?
I'm not that kind of data scientist practice. No, I don't know.
Is it a fixed fee or per user or?
It's complicated and it's changing a lot. It has changed a lot since the acquisition. So we're really targeting very big clients only, and there are a few different plans, but I don't really know the details. So I can get you into contact with somebody who can tell you stuff without hand waving.
How do you determine sentiment? Do you just look at certain words, or do you try to actually analyze the sentence and see if there's a verb in the sentence? How do you do that?
Right. Yeah, I realized that in the title there was NLP as well. I didn't say anything about NLP. Because at Engagor we don't really do very sophisticated stuff regarding NLP. So it's just bag of words with some small tricks, you know. Now, of course, at Clarabridge they have a completely different take on that. So they really do have symbolic, sophisticated grammatical language models that really go deep into the meaning, semantics and we're now in the process of combining these things.
So you would be able to detect sarcasm or irony?
Well, Microsoft says they can detect sarcasm and irony, but I don't know. We can't. Yes?
You said that you have more than 6,000 models.
Yes.
But, can you explain why do you have so many models?
Because basically we need a model per tag, and that's the amount of tags that are being used currently by our users. Yeah. Okay. Thank you.